Hello guys, welcome to another video, and in this video we will be looking at data structures. What are data structures? They're just way from the word structure. It's just the way we have our data organized, and Python have a few of them with very unique characteristics. Okay, let's just jump into it without further ado. Now, when we speak of data type, earlier we were talking about when we speak of data structure, earlier we were talking about data types in one of the previous lessons, and I explained the fact that sometimes you can see some of these data types as, or some refer to them as composite data types, right? So whether you see them as data types, where we have the primitive ones, which are integer, string, and the rest, and you find this, or you see this, or regard this as composite data type, you're still not wrong. Okay, so the idea will be that composite data type can take more than one value at a time, right? It can help you hold more than one value at a time, hence the word structure, right? There are fundamental ways of organizing and storing data, and it makes access and modification efficient, right? So you don't have to store, imagine we have to store a single value in a single memory address. We can store multiple values, right? And that will make modifying and accessing a lot of work. So Python has some inbuilt data structure that help us achieve way more than we can get with primitive data types, the likes of integer, string, float, boolean, and the rest. Okay, so let's just look at what we have, and the first one we have here is called a tuple. Tuples are ordered. Now whenever we have the keyword ordered, this would mean they can be accessed, values in them can be accessed using indexes such as 0, 1, and using the position. The same way, let's say for example VLOOKUP function in Excel, where you pass in the column index or the row index, right? So that's for each lookup row index. So tuples are ordered. So when we speak of order, it simply means they can be accessed using index. Immutable means they can't change. They are unchangeable. Once you have saved something in them, that is the end. That is all. You can't change them. So once a tuple is created, its elements cannot be modified, added, deleted, or removed. They are often used for heterogeneous data types and sequence that should not change. So you have to keep that in mind. Very important. Okay, let's just jump into it and create a tuple first. So let's just say my tuple, and then we'll have, now we create them like this because they are noted, or they are represented using this parentheses. Okay, parentheses. So do one, then I can do apple. I can put that in capital, apple. Then I can do, let's just put a number, say 3.14 pi value, and then we'll just say true, which is a boolean, true. So we can print it just in there like that. Print it, and then let's use a formatted string. My tuple, I want to see the value in the tuple is my tuple, and then we want to have let's put a pipe symbol, so we should escape this so that it doesn't see it as an OR operator. Okay, so we'll escape that string, and then we'll put it the type. So we'll say the type of this, my tuple is type of my tuple. No, there should be a single parenthesis. So my tuple. So this is what we have. We created the tuple here, and then we want to print it out to see what it looks like. So run that. Okay, it's just connecting. I think I'll zoom in as well. Okay, this is better. So for passing the value of 1, you can see we have mixed data type in here. This is a variable that will hold the value of this tuple. Okay, the variable will hold the value of the tuple. Okay, so this is what we have. Now it's complaining about the pipe symbol we have right here. It's complaining about the pipe symbol we have here. So let's just put a comma instead. Let's put a comma and we're going to execute that. Okay, so it's saying my tuple, this is what we have inside the tuple, and the type is a class of tuple. Now, something is very important for us to know, that whenever we want to have a single value, let's assume we only have a single value to put in a tuple for now, we must have a comma after it. Now, what does that mean? Let's see it quickly. So let's say we have a tuple. So say new tuple, new tuple, and then we'll say let's say crack. So this is all we have, or this is all we want to put into this tuple for now. And of course, because tuple are denoted using the parentheses, we have already put it in there. So real new tuple. Okay, let's say real tuple fake tuple. Let's just put it that way. So real tuple, fake tuple, and then we'll pass in something else. Now let's start with this first. So here we want to print out the type. We'll just say type of fake tuple, and then we'll run that and see what we get. Let me comment this out, run that. Now you can see that this type is of string, and the reason for that is simple. Whenever we're passing a tuple, a single value like this will not result in a tuple. And why is that? Usually tuples are more of a pair. They're usually in pairs, so a single value cannot be a tuple. Okay, so for example, we can have them as coordinates and examples on things like that. So in this case, what do we do if the only value we have is just 1? And do not forget that we cannot modify them as well. But let's see what we can do. So now I'll go back to this and uncomment it. I'll put in the same crack here. Then I'll just add a comma, just a single comma. That does the magic. So now I'll print the type of real tuple. So I'll just say print f. This is an actual tuple. This is an actual tuple. I'll just copy all of this. This is not a tuple. All right, so we have this, and then we just put a curly bracket, and then put a curly bracket here. Type. All right. So I want to print this and run both of them, so you can see this is not a tuple. This is not a tuple, class of string. This is an actual tuple, and that is the class of tuple itself. So it is important to know that whenever you want to put only a single value in a tuple, let's say for the time being, you should make sure that you had a leading comma. Is it a leading or a trailing now? Comma to it. Okay. All right. Let's see how we can access elements in tuple. Now, one good reason we'll be able to access elements in tuple will be because they are ordered, right? So since they are ordered, we can access elements in tuple. So let's just print. We'll just print the first element, or let's say the second element in tuple. The second element in my tuple is my tuple. Now, how do we access elements? We'll type the variable name holding the tuple first, and as usual, the same way we can do for string, we open a square bracket. Now, using a square bracket is general for accessing values. It's not limited to, say, for example, list that we'll see later, because lists are denoted using square brackets. Okay. However, to access values, we use a square bracket, and this is general for accessing values. Whether we have a string or we have anything at all, we can use a square bracket to access values. So in this case, indexing starts at 0. So if I want to access the second value, what's the second value here? Apple. So that means I'll be using 1. If I put in 0, it will show my first value. If I put in 0, it will show my first value. So let's run this and see what we get. Okay, so you can see it says the second element in my tuple is what? Apple. So if I change this to 0, this will give us the first value. This will change to 1. And that's what we'll be saying, that we'll be saying 1 in there. Okay. While that is loading, okay, it's out there. So we're having 1. So since we put in second element, I'll just keep it at 2 right there. Now let's attempt to update or modify a tuple. Okay, so we have my tuple. So I'll say my tuple, then a square bracket. Okay, just to access or to modify a tuple, we'll put in what we want to change. So let's say, for example, 1. We know what is in the second element, which is apple. So let's say we want to modify that. We want to change it to banana. Banana. I want to change that to banana. Okay. This will throw an error, but let's see what the error will be. Okay, that's probably network. Let me just do something about the connection. Okay. All right. So here we are. And if you look at this, you can see that it's saying, oh, tuple does not support item assignment. We know what assignment means. That means using equal to give value to a particular variable. Now, it's telling us that no, I don't support that. So now that we know that tuple does not support assignment, what can we do? What is the workaround for us? Because we have an actual workaround. Okay. And the workaround is quite simple. Okay. All we have to do is put in, say, my tuple equals to my tuple, then plus what else we want to add. But this way we cannot update it. We can't add anything to it. Okay. So we cannot add anything to it. It doesn't have the likes of, since it doesn't have the likes of other properties or attributes that some of the data structures we're here to look at as. Say, for example, my tuple dot append. Maybe, okay, add something, append, add at the end. We want to see if this can take banana. Maybe we're not even modifying, we want to add new value, banana, and we run this. Let me just comment this out. Okay, the first one is still showing error. Let me comment it out. Let me run this. It's going to tell us no attributes append found. So literally, we cannot add a new value. We cannot modify existing one. So what can we do instead? What we can do instead, which is the workaround, is we have our tuple. We can now add new list of tuple this way. By default and by its nature, again, it is what? Immutable. We can't change it. So what do? We can now say laser 200 false. Okay, so this is what we want to add to it, and we remember that doing this, we have a better way of doing this using the assignment operator, which is plus equal, right? So that means we can rewrite all of this as this: plus equal this, which is nice. So I'll just comment this so that you can see that instead of writing this way, we can write it this way. Okay, I think I'll just put this in front instead, the workaround. Okay, so this is what we have, and if I run this, let me make sure I print it down there. Print my tuple, then the type of my tuple, okay, so let's run it, and you can see it has now included that to the list for us, and it's saying what? It's still of the class tuple. All right, now tuple unpacking. This is a great way to split values into multiple variables. It is a great way to split values into multiple variables, and it is as easy as it sounds. So let's create a new variable. So let's say coordinates, then 25. Let's say longitude and latitude. And then we can say long and lat. Now that is highlighted in a very special way. Let's work with it. Then we can say we'll pass in coordinates. So what does this do? This grabs the first value, puts it into longitude, grabs the second value, put it into latitude. So we can now print using the formatted string. So we can say longitude. So longitude is this, long, and then latitude. The short form for longitude is that's LON, or we can use LNG. So I'll just stick with LON. All right. So this is better, LON, and then we'll say latitude. So latitude is LAT, like that. Nope. Okay. So this is what we have, and we'll see how Python will automatically split it for us. And you can see longitude is now in this variable, and latitude is now in this variable. And this unpacking is very useful, not just only for tuple. Okay, it's way useful. We can use it to unpack list and the rest of the thing. The most important thing is that the list of variable must equal the list of items in that variable. Okay, that is something important to keep in mind. So finally, on tuple, let's look at swapping variables. How can we swap variables? Okay, so let's just do something simple. Let's say a comma b is equals to 1 comma 2, and we want to swap that. So we can say a comma b is equals to b comma A. As simple as that. So let's print A at this point and B at this point so we can see the difference. So print, and then we'll say before swapping. So before swapping, A is A, B is B. Then we'll say after swapping, Control C. Let's do it this way. After swapping, A is B and B is A. So let's run this. And you can see before swapping, A is 1, B is 2. After swapping, A is 2 and B is 1. So this can come in handy and it's very important to know. Alright, so that is what we'll be looking at under tuple. And the immutability. Now, because tuple are not changeable, the immutability of tuple makes them faster to loop over than list for iteration. That means iteration is to loop over, and are often used as keys in dictionaries, which list cannot be. So of course you have not seen list. We'll look at that later. And one key thing is that they also provide a sense of data integrity, as the content cannot be changed, so you can trust it that okay, if this is what is returning, then that is it. Of course, don't worry about the workaround that you see. It cannot be updated, right? You cannot change the value of a part. You cannot update the value of the tuple, right? If we keep going for tuples, we can see that oh, it has good other benefits. Okay, so just a pro tip: use tuple when you have a collection of items that logically belong together and whose value shouldn't change, like coordinates, RGB color values, or database records. Okay, so you can use list when you need a collection of something you can modify, right? I will be saying list shortly. I intentionally brought these two up because we'll be spending more time in list and dictionary, as we use them more often than tuples and sets. Okay, so this is what we have under tuple, and now we'll jump into set. Now for set is unordered. Now, like I mentioned earlier, if we say order, that means we can access using index. So since it's unordered, we can simply tell what that means. We cannot access using index. Okay, so and it is unique. It is unique. They can't have duplicates. All right, a set cannot have duplicates. It's a good way of removing duplicates. So let's just jump into it and see what we can do. We'll just create a set of numbers and then check how duplicates are automatically removed. So I'll just keep everything in a single cell. Hopefully we'll add them somewhere else. Okay, to make it easy, I'll do it this way, then create one at the top and paste it there here. So we'll see the set, and then we'll say my set. Just do it like that. My set equals, oops, how did I jump in there? Let's just use numbers in this case. 1, 2, 3, 4, 5, 8. Okay, so from here we'll do 2, 5, 4. So we have 2 repeated, we have 4 repeated. Okay, so let's print it. Let's print my set. Print my set. Close the bracket first. Now print my set. Now putting my set in there, and the type of my set is type of my sets. So that should be the parentheses in here, my set. So this is what we have, and let's see how duplicates are removed automatically. And you can see we have 2 here, we also have 2 here. Okay, we have 4 twice, but you can see what it printed for us. It's removed all the duplicates automatically, and you can start thinking of how this can be helpful. Okay, because your mindset was your learning should be, oh, how can I apply this into what I already know, or into what I use often, or into what I might want to do later. Okay, so these are things you should always keep in mind. So let's move on. Now we want to create an empty set, because we can. Okay, we can. Now when creating sets, it is important that we don't use curly brackets. Why? Because we have another data structure that uses this. Okay, but there's a difference between them. So to create an empty set, what we use instead is the constructor. Okay, so I'll say empty set. We already have my set, so we'll call this empty set, and then we'll say set. And if we can use the constructor, that means we can also convert something to a set, right? And also convert something to a set using the constructor, and that thing can easily help us what? Remove duplicate. Okay, if we have a list that we want to remove duplicate from, we can just pass it into the constructor like this, and we'll see what we have. Okay, so now we are creating an empty set, so I'll just copy this and then print it down here. So empty set, and then yeah, just run this. Okay, that's because I'm printing my sets. Let me change this to empty set. Empty, and this also should be empty. All right, so you can see it's just saying empty sets, and it's just showing the constructor itself, because we do not have anything in there. Okay, we don't have anything in there. So let's see how we can add values into the set. Let's add value into the set. So we can say empty set using the dot notation. Now once we add the dot notation, the amazing part of it is that it shows us all the methods we can use, right? You can see, so we don't have to memorize them, as it were. Okay, so dot add, and then, and this also applies to basically a variable name. So when you have a variable name and you use dot, now depending on the data type of the variable, you will see the methods you can apply to that particular variable. So this is a very key takeaway for you, and a pro tip that you should always remember. So you don't have to memorize too many things that, oh, what can I do with it, what can I not do with it. Okay, so let's say I want to add let's just add 90, and then we'll print it after adding something to it, but we'll not be printing the type again in this case. We already know it's a set. So after adding a value, all right, so you can see after adding a value, we get what? We get 90. So now I can just modify this and say 9 3. So run this. Now it says what? It takes exactly one argument. So this is important to remember, that we can only pass in one value in there. So take this out and then run it this way. Now you have what? 9, 90. So we can keep adding the values that way. Now we'll try to add what we have before. Okay, we'll bring this up, and you see that it has no effect even if we didn't do it upon creation. So copy this and paste. So I want to add 90 again, another time, and I'll run it, and you can see it's not printing 90. If I had say 27 and I run it, we now have 27 in that list. So duplicate has no effect on tuple. It is very important to know that duplicate has no effect on tuple. Now let's see how we can remove element from a tuple. Let's see how we can remove elements from a tuple. I think I can just put this together in a single cell. So we'll do this code, paste here, hashtag, end space. So we'll do empty set dots, or let's use our set. What do we have in our set? Quickly, let's check. What do we have in my set? Okay, we have quite a number of numbers there. So we use my set dot remove. So I want to remove a number from the set. So let's say I want to remove 8. Let's run this. Oops, it's saying, oh, you see, it raised what? Key error, because item is not found. It's telling us, okay, I don't know this 8. There's no value in there. So what can we do? We can use another method to safely remove without raising error, and that is called discarding. Okay, so that is discarding. I think this is better up. Okay, this way. Then we can just say my set dot discard, and then I can say 10. We still do not have 10 in there. We don't have 10 in there. So let's print my set so that you see it before we remove my set. We don't have 10 in my set. So let's check this out. Okay, this is still raising an error, so let's comment it, run it now. You can see we have 1 2 3 5 6. So this didn't show any error because we're using discard. So it's a safe way to remove something. But if there's actual value there, so control/ removing an actual, or removing a present value, removing a present value. So let's use discard now. So my set dot discard, then we'll say 6. Okay, or let's put something in the middle. Let's just remove from the middle. Can remove from anywhere, by the way. So now print my set right after control. So before it had 6 at this point, but at this point it had 6 elements. I mean, at this point we just have 5 elements and 3 is gone, right? So this is a safe way of removing elements in a set. Now the next thing we want to do is set operation. Okay, so let's create a variable quickly. Let's just say first set, just have a number of 1 2 3 4, 1 2 3 4. Yeah, like that, right? Okay, like this. So 1 2 3 4, I want to have second set. Second set will just be 3 4 5 6. 3 4 5 6. So how do we check for the elements in A or B or both? Okay, the elements in A or B or both. So we can do a union. Okay, so right here we'll just say, let's just say print We'll just do a print, use our f string, and then we'll say union. That's inside. So open a bracket. Oh, okay, I put the f in there. All right, f should be outside. I will say union. Yeah, union is you're bringing together. Okay, you're bringing together. So this gives us the combination of A and B. Okay, so I think I just put elements in both. I'll just put it this way: elements in both. Union A. Pipe B. All right. Then we can put a column right here. Then we want to do set or first set dot union. Then we'll pass in second set as the argument. Second set as the argument. Okay, so we want to see what that looks like. So we can just always use this and run the update. So you can see it combined both lists for us. So that's combination of both from the word union, coming together of two different things. Okay, now the next one is intersection. Okay, I think this should have been intersection then union, but I'll just take that out. So union, this is elements in A. Yeah, the comment is right. Elements in in A and B, excuse me. So do print. Let's just copy this. We'll copy this, paste right here, and then we'll have it as intersection. That's the intersection of A and B. Now the symbol, the mathematical symbol for that is the and sign. So that's why it's A and B. This works as an or, right? Remember earlier when we wanted to print something, I think somewhere around this top one, I used the pipe symbol, right? And I said we wanted to escape it, but it's not letting us escape it the way we wanted to. So we have this. Okay, speaking as text literally. So the escaping was the tricky part. All right. So we can say first one, first A, that's dot intersection. So we're intersecting the first set with the second set. So we'll print that as well. So you can see 3 and 4. It only picks what is common to both of them. It only picks what is common to both of them. So difference. Now let's do a difference. Let's pick this. So say difference. And for the operator, the sign operator for difference is just basically minus. Okay, that's A minus B. And then we'll change this to difference. And of course, we'll still look at symmetrical difference later. You say A, but not in B. So you can see 1 and 2. These are the things we don't have in the second set, right? We don't have this in the second set. We have 1 and 2 in the first set. Now, that means if we switch it, that means if we switch it to B minus A, B minus A, so we get second, and then we change this to first. All right. So control enter. So you can see we're getting 5 and 6 instead. Now, let's look at how to get the symmetric difference. Now, the symmetric difference is where we get elements in A or B, but not in both. Okay. So just copy, paste, Then we'll say symmetric difference. Symmetric, right? Yep, that's correct. So symmetric difference, and the sign for this is the caret operator or caret symbol. So symmetric difference, first set, caret, second set. So we'll run that again. Oh, sorry. Let me change this to symmetric difference. Symmetric difference. All right. So we'll execute that, and you can see we have elements in A and B, but not in both. So we have 1 and 2 in A. We have 5 and 6, but we have 3 and 4 in both. So it excludes what we have in both, and that is a symmetric difference. That is the symmetric difference. Okay, so all right, we'll just keep the set operation in a single cell. And lastly, for checking membership, and this is also very fast for set. Checking membership in set is way fast. Why is it fast? I mean, I think we should know that already. It's simple, and that is because the first thing is a bit more technical, is the hashing part of it. Because when you add a value to a set, and there's an hashing there's an hash algorithm behind the scene, you have numbers, and it's very fast. No, let's just leave the parts. It has some other complex things to it. Now, but two major things that we can easily relate with is lookup. The first of all, the no duplicate value. Since there are no duplicate, there is no extra, jumping up, coming down. And the second thing is that it has no order. So because it is unordered, that means if it's ordered, that means it has to go over the index 0, 1, and then keep checking. But in this case, since it has no order, it doesn't follow let me start from the beginning. So it makes it faster to pull out a value. Okay, so let's just create a set of values. So let's say employees, and just say Jack owns stone cold. All right, just keep it as this, and then we want to say for, right? Well, we necessarily do not need to use a for loop, so we can just say if. Let's just say if a particular person, in this case, if code in employee, if code in employees. So what do we want to do? I want to say member yes, code, because we are using the actual name, code is an employee. Okay, so this is what we have, and let's see what that looks like when we print it. It says, oh yes, code is an employee, not employees, employee. Okay, so if it's not, then we'll say, oh, this person is not an employee. So this is how simple and fast, and this is one of the reasons why, or some reasons why, set are faster for membership operations. So finally on set, see what we have, and this is the same thing we have literally done up here, but using the operators in this case. So if you see, of course, it only prints the last one. So we can just wrap this in print for union. Okay, let me bring that down. Then okay, click that. All right, so I'm just activating the multiple cursor so we can type fast. Okay, so do a print, open, and then we'll come all the way, then we'll close the brackets. All right, so control, you can see all of them just like that. You can take your time to go over this particular example, using just the operator instead of this long place where we use the text and all of that. They do literally the same thing. Okay, so sets are excellent for finding for quickly finding unique items in a collection, performing membership tests, and executing mathematical set operation. If order doesn't matter and you need uniqueness, set is your go-to. Okay, so you want to keep that in mind as much as you're progressing. And the most important thing is that you start thinking of application. However, just a quick letting the cat out of the bag, or letting the bag out of the cat, yeah, is that we still have incoming practical application where we'll now look through various examples, applying everything we've learned so far. This will not be an exercise for you to do, it will be an exercise we do together. Okay, apart from the mini ones you've been getting, we'll be doing this together. And yes, you can see that there's also an error handling session coming, and I also have a bonus for you. And what that is, you'll find out when it's time. Okay, let's jump back to this. Where we now? All right, so we have seen sets and we have seen what we can do with sets. Now we want to look at lists. Now, if you pay attention quickly, tuples use parentheses, sets uses square bracket, curly brackets, list uses square brackets, and dictionary, let me collapse that, which is the last one, dictionary uses curly brackets, the same as set. But in this case, this is a key and a value, which we'll see in a short while. So let's look at sets. Now, for a list, for lists are ordered, they are mutable. That means they can change, and they can hold, of course, as we have seen with the rest as well, they can hold different data types. So the first thing is that we want to explore different ways of creating a set, a list. Sorry, we just left list. It seems I've not let lists. We just left sets. It seems I've not let sets go. But I think I'll let sets go now. So using square brackets, have that at the top. Just to make things faster, we can have everything in here. So empty lists, just call it empty list, and this is it. It's as simple as this. So we can create a list with mixed data type. So let's just say mixed list. Let's call them what we want to create. So mixed list. So it can be let's say user ID 001, Jack, we can say Jack at tfa.yt. We can say Jack is 35, and yes, is a graduate. True. So this is what we have for mixed list. Using the constructor, okay? The constructor, just like we did with sets, the constructor is just where we type in it looks like a conversion, right? Data type conversion, where we type the variable or the data type name, open a bracket, and pass the values we want. Okay, so we can say tuple to list in this case, and we can say list. So we have list of a particular tuple 1 2 3, right? You know, this is a tuple, right? So we can say list to tuple. We can use range to generate a list. Range list. By the way, what is a range? A range simply generates numbers. Okay, so we'll have to use the constructor in this case to convert it to a list. So say range, and then we can say start at 1, stop at 5. Why? Because the last value is not always included. And do not forget, hovering on your function name tells you, gives you the documentation string about it. In Excel, we call that function string tip. So do well to always read. You can start using from there. You can start using some of the methods or some things or some functions you don't even know before, right? By just reading, and then you try them out. So this says start, stop, step. So for the stop, see, start is inclusive, stop is exclusive. So that means if you look at the stop, that's -1. Look at it, -1. High, which is the first value, the start. J is the stop. The last value will be j -1. So, but so far progressively, it is j plus 1, I plus 1 plus 2 plus 3 plus 4. Except we had a step to it. Okay, except we had a step to it. So that's range. So this will give us, in reality, 1, 2, 3, 3, 4, 5. So that's all this will give us. Okay, that's what this will give us. Which is the same thing as from a tuple. So we have done that already. We don't need to do that again. Okay, that is out now. And what we can also do is to do it, we can create a list from split. We can say, okay, I think we have a list of employees somewhere. We'll just create another one. Okay, so we can just say, let's say students this time. So we can do Alice Okay, so we just have this, and then we'll do dot split, which is a string method, right? We've used this before, and just take this out because it's literally the same. So let's print out all our list and see what we have. All right. First, empty mixed tuple to lists. Okay. All right. First, did I say first? Empty list, rather. Empty list. Then we want a \n. Then we have mixed list. Mixed list. Then \n. Then we want tuple to list. Tuple to list. \n. By the way, \n is just to put it on a new line. Range list. \n. And then students. All right. So we'll run all of that. And you can see what we get. The first one is empty. The second one is like this. The third one, the fourth one. Right. This is where we did the split, and you can see that is now seen as individual values. Right. So the next thing is indexing and slicing. Indexing and slicing. So for indexing and slicing, is something we've probably done before using the string methods. So since lists are ordered, we can access them and slice them using indexes. Okay, and access them and slice them using indexes. So let's see what we can do. We'll use our student list. So students, and remember to access or slice, we open a square bracket, right? Then we can say 0. This grabs first student, and we'll run this. You can see that is Alice from this list. So that is our indexing, and we can do a negative indexing to get the last person. Say the list is long and you don't want to count, or you can count, so you can do students -1. Students -1. Now the beauty of this is, let's consider this as number line, right? Where you have 1, 2, 3, 4. Now the first value is 0, right? On the other part is what? -1. So let's say -4, -3, -2. So if the first value is 0, that means from the back, it will now be -1, -2, -3, -4, -5, all the way down like that. But if we're going from the starting point, it will be 0, 1, 2, 3, 4. So you might want to keep that in mind. All right. So say last student. Now run that. Of course, we only see this. So let's put them in our print so that everything gets printed. Print, open. All right. So we get both of them. So this is accessing or accessing. Or let me just use the word indexing. Indexing, accessing values. So the next one will be indexing. The next one will be indexing but slicing values. Okay, that'll be slicing values. Let's add a new code. And then we'll say slicing values. All right, so we'll say slicing values just like that. So let's say I want to grab these two names. How do we do it? We can say student. Start with student. Now open a square bracket. So consider it a range, right? In Excel, when we highlight B2 to B4, it will be B2 colon B4, right? So we're saying starting at B2, stop at B4. The same way in Python, we start at the first index, and value here is what? 1, index 1. Then we use a colon. Then we say, where do we want to stop? Now, again, the stop value is exclusive. That is -1. So if we want to get Charlie as well, we have to put the value for Doc. That will be 1 colon 3, because it will not include the last one. Okay, so print, then we'll control, and you can see what we have. And right there we have Bali and Charlie. Okay, we have Bali and Charlie. Now let's look at how we can grab the last two. Okay, let's see how we can grab the last two. So we can say print students. We can say, now we have to count. Okay, we have to count. That's 0, 1, 2. That's 3. So we can say 3 to 5. Even though we have 4. 4 is the last index. We have to put 5 so that we can grab or get the last value or the last student in there, which is Evelyn. Now, when we are grabbing from the starting position, we do not need to specify the starting position anymore. If the starting position is 0, we don't need to specify it. So let's say, for example, I want to grab the first 3. I can do something like this. Students. So we'll do square brackets, then we'll put the colon. So in this case, we can ignore the starting point since it is beginning from the very first item. Then we put 3, right? Because that will grab the first, the second, and the third, which is 0, 1, and 2. Let's print that, and you can see right there. Okay, the same thing happens for the last. So if I want to grab the last two, unlike how we did it before, we can just use negative indexing. So we can do negative indexing, and we'll say print students. Then I'll just do -2. Okay, why? This is minus, just come off there. This is -2, right? This is -1. Evelyn is -1. Doc is -2. So we're picking from doc all the way to the end. Since we're going to the end of the list, we don't have to specify. Okay, and you'll see that this will be the same as this. So let's check it out. So you can see we're able to access it that way. So let's make it more fun. Let's spice things up. Nested list. Nested list. Okay. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what an amazing list we have here. Okay. So, yeah, that has been executed. So let's print nested list. Print nested lists. We can see what we have. Now, how do we access value in this case? So, let's say we want to grab 7, right? We want to grab 7. Now, you access them by the square brackets. All of this has a single index. This is 0, this is 1, this is 2, this is 3, this is 4. Okay, so don't get confused. Everything in this square bracket is 4. Though it has other values in it, then because of the values in it, we can now start from 0 again. So it resets at this point. What does that look like? Let's say I want to grab 7, right? So that will be print student. Then we'll say 4. So let's print out 4. We can do it step by step, right? So we get to see what we have. Oh, I'm still using students. Let me do nested list. Nested list, okay? So let's run this. Now you can see nested list grab. Let me stop printing this now. Nested list grabbed everything in this square bracket for us. So that's step 1. So now move on to the next step. We need another square bracket. That means we want to enter this one. So in the front, we now put another square bracket. Do not forget we want to grab 7. So 7 in this case is what? 2. And I'll print it. Okay, I think I should do it this way. Control C, Control V. So this stays here. And then we'll print this. Now you can see that has grabbed 7. What if we want to grab 9? You probably guessed right. If we want to grab 9, we'll put it as 3 first. So let's print that. It's grabbing 8 and 9 for us. And then down here, we can do 3. And then we'll put 1. Then we'll run it. And you can see we have been able to grab 9. So it's nothing to be intimidated by. No matter the number of lists, just calmly add more square brackets. The same thing works for dictionary that we'll see shortly as well. Nested dictionary, nested list, list inside a dictionary, dictionary inside a list, tuple inside a list, list inside a tuple. All of those things, you access them. As long as it is ordered, you can access them this way. Okay, so yeah, now let's look at some common methods in lists. So collapse all of this, collapse this as well. Okay, indexing and slicing, thank you, we've seen you. Now let's look at some common list method. For example, we want to sort, we want to do different things. Let's just say data. Let's just call this data. I'll just use some simple numbers. 3, 1, 4, let's say 5 now. Then we have 9, then we have 2, then we have 6. Okay, now we can add more numbers, but let's work with this. Now for sorting, a simple data dot sort. Like I said, based on the data type in a variable, once you put in the dot notation, it shows you everything you can do. And you can see sort is right there. So we'll say sort, and then we'll put it there. So it sorts the list in place. right? This modifies the original list. That's something you should keep in mind. So let's say print f string sorted lists. Let's add the word data, sorted data list. Now we can say before sorting as well. Let me add this data. So we'll put this up and say before sorting. Original data list, and then we have the sorted version of it. So it modifies the original list, right? Don't forget that. So let's just take this out. In place means except we pass it into another variable, right? We can say sorted, because we have not executed it. If we say sorted list, that means the original is still the way it is, and then this is what we have. Let's just leave it that way. We want to have the numbers sorted. So let's start with this. So print them, and you can see the original list is sorted version. Easy peasy. Very important to know. So let me grab all of this into different code cell, run that again. All right. So let's do reversing the list. So we want to be able to reverse the list as well. Let's bring in the list somewhere else in a separate place. All right. So reversing the list, of course, it also reverses in place. And let's see the difference between reversing the list and reversing it in place. So I would like the original data list to be printed every time we do something to the list. Oops. So, but now that the list has been modified, we will not be able to see that again. So, because sorted, we overwrite the original list. Okay. So let's just do Ctrl V, reversed data list. Just say reversed data list, and we want to print data. And how do we use that? Very simple. We just say data dot reverse, and then we'll print that. So see what you have, descending order. So you sort ascending order, descending order. That's just basically what it is. Now let's look at counting the number of times we have something in a list. The number of times it appeared in a list. So counting, we can call it frequency. Okay. So we can say data. Let's save this into another variable. Count number of one. Count of one. Let's just put it count of one. We want to see how many ones we have in our list. So say data.count. Then we'll pass in 1. Then we'll print that right here. Down here. Let's copy. Okay, I think we still have it copied. Okay, we don't. In the clipboard, just paste this now. Then we'll say count of 1. Or number of ones. Number of ones. So we'll pass in count of 1 in here, and we should have just 1, okay, because it is just 1 that we have. All right, number of ones is 1. We don't have multiple of them. Indexing. So what if we want to find the index? That means the position of a value. We want to find the position of a value. We want to find the position of a value. In that place we can we still have this copied. So we can say index of 1. We'll just get the index of 1, and that should be 0. Index of 1. Then we'll say data dot index, no, index, and then we'll pass in 1 as well. And then we'll paste that. Oops, okay. We copied from on the side. So I'll just put index of 1. There's no need to type it differently. So change this to index. We'll run that. Index of 1. Let's print our lists right here. Print data. Okay, so let's run that. Oh, right, reversed. Remember, the last thing we did is that we reversed the list. Okay, so since we reversed it, it is now the index of 1. All right, so that's just a quick check to show we are on the same side. Quick check. All right, because it should have shown us 0, but we reversed the list. All right, what about we extend the lists? That means we're adding one list to another. Let's see how to add one list to another. But I think before that, we should see how we can say, for example, data 6. This gives us what? 1. Let's say equals to 12. So let's run that and print data. All right, so you can see we now have 12. Okay, so this is updating. So I want to see updating first. Updating a list. Updating a list item. Yeah, that's the word. Okay, updating a list item. Now the next thing is to extend the list. So let's say we have more data, and then this is 0, 12, 13, 7. Okay, so we can say data dot extend, easy peasy. Then we just pass in more data. So when we print and this also should be data. This should be updating the value of index 6 from 1 to what will be there. So that means we're updating the index value. Okay, let's just put 6 here. So from 1 to 12. So it has changed. So this will now be extended lists. So we can just call this extended list. And we'll be passing data in here. We'll pass in data. So you can see we now have the new list. So you can try sorting data dot sort. Oh, sorry. So this time we're getting an error, and the error is because we had numbers, but now we have string. Okay, so we have string. What do? That means you cannot, is not able to sort, see, using this operator, because it's trying to see which one is lesser, and then it sorts using that. Okay, so we might want to update the list first before we remove the so that we update the value to an actual number, and then we get the value we want. Okay, so let's move on to clearing a list. Okay, clearing a list. So to clear a list, you can see data.clear. So I'll just uncomment this. And if we print data, boom, empty list. Just like that. What other methods do we have? We have pop that removes a particular value from a list. We have okay, let me just put them this way. Or better still, because we can't cover all the values, we can just do something on more list methods. Data dot. So using the dot notation, you can look at it. We have pop, which removes the last value in a list. We have append, adds a value to the end of the list. I've seen clear, copy, reverse, pop, and all of those things, right? So we can say use the dot notation, use the dot notation, because they are methods. Use the dot notation. Okay, so let me just say use dot pop, for example. There's nothing to pop, trying to get other methods. All right, so and yes, that brings us to the end of what we want to look at in lists. And yes, pro tip, lists are very versatile and one of the most used data structure in Python. So understanding indexing, slicing, and common methods is crucial for efficient data manipulation. Okay, and that's why, like I said, when I started, I pushed them down and I started with tuples and set first, because we'll be using more of lists and dictionary. Okay, so now that we're done with lists, we can now go to dictionary. And for dictionary are unordered collection of key value pairs. Unordered. Immediately you see unordered, your mind should go to, oh, we can do 0, 1. We can access them using index. So each key must be unique and immutable, like string, number, or tuple. Okay, it maps to a value. Dictionary are incredibly useful for storing and retrieving data by a meaningful identifier. Okay, so let's see how we can create some dictionaries quickly. So the first one, we just do a D. For empty dictionary, we can just use our curly brackets. Okay, remember, we can't use this for sets, but we can use it for a dictionary. So we can say D1. So this will be D0, D0, D1. Say dict. That's using the dictionary with items or the constructor. Okay, now let's put this right here. I just have them scattered all over. Okay, so this will be D2, then D2, empty dictionary. So dictionary with items. So we can just say math 70 or 70, English. Okay, this is a column. English, want it to be 50. Let's just keep it at this 2. So we'll print all the D's. eventually. We'll print them eventually. Okay. So the next one is to use from our constructor. So this is the way to use it from a constructor. And for empty ones, we have it this way. D3. To use the constructor with keywords. Okay. I want to use it with keyword arguments. We'll say, let's say dict. Then we'll put in name, for example. Then we'll say okay. Then we can say city. Kanzerina. Don't worry about the city. It's somewhere in the world. And then the age. And say the age is 45. Okay. So this is another way. I'll go very slowly. So the first one using an empty square bracket. The second one is just with an item where we have a key and a value. Why is it called a dictionary? In a dictionary, you have a word and the meaning, right? So that's the idea, the key and the value. To get the meaning, you need the word. You can't get the meaning of nothing. I mean, nothing has a meaning, but you can't get the meaning of nothing, literal nothing. Like, you want the meaning of something, but then you have to like remember it. It's just like when you're, oh, do you know the meaning of this word? And then you're finding it hard to say the word or to remember the word. You can't be given a meaning, right? Because you need a word before the meaning. So that's what we have. And using the constructor as usual, just type dict, and then we pass in the value. So this one now is for the keyword. Okay. Keyword. Remember, this is like a variable, right? So we are passing it in here. Oh, name will be this. This will be this. And now let's try with a list of key value tuples. Okay. So we can just say D4, and that will be, do not forget, a list of key value tuples. So a list first of tuples. And now in this case we'll have name. Let's just use the same person. And then we have it as train. Then we'll say city, so that the example can stick. City, comma, it's a tuple. So just grab this guy, grab that guy, paste it here. And then we'll say last tuple, we'll say age. And in this case, we'll put in what? We want to put in the same age, right? Just put in the same age. That's 45. Person is not suddenly older for us. So this is what we have. Now, finally, to turn this to a dictionary, all we have to do, very simple, nothing tricky in there. We just have to use the constructor method. So we can say D. So I think this should be list tuple or a tuple list. Yeah, a list of a tuple of a list. Tuple list, yeah, tuple list works because currently it's not a dictionary yet. So D4 will now be equals to dict, and then we pass in our tuple list like that. Tuple list. Hold on. Tuple list. So now we have been able to see different ways of creating a dictionary, and yes, we still have more. Now this is another way of doing it using dictionary comprehension, the same way we have for list. Somehow I omitted that one because I don't have the comment somewhere in there. Okay, because I don't have the comment in there. So we have list comprehension, which is a faster way of using list. It kind of uses it uses the for loop in a square bracket, so we can easily do that for a list. Okay, in this case, how do we do this? So using dictionary comprehension, we want to map numbers to their square, so we can say d5, and then we'll start by a curly brackets, right? Because that is how we recognize a dictionary. So we'll say x, then we'll say x raised to the power of 2, or we can just say x times x. Now consider this a small lambda function, right? Remember, the only thing we're missing here is just to say lambda, right? Okay, so we have lambda x, then the square of x, then we can say 4. Okay, so what should you square? For x in the range of a value, and the range of a value in this case is just a 1 to 5, because 6 is not inclusive, right? 6 is not included. And when we print this, we'll see the results of it. All right, another method is to use dots from keys with a default index of 0. By default, the index starts at 0. Okay, so let's see how we can do that. We can just say d5, or we need a pre or a staging part. So to stage that, you can just say from keys. Now from keys, so let's just put in Japan. Okay, let's put in continent instead. Africa, Europe, oops, I executed that already, and Asia. I should have executed everything anyway. So from keys, now we can say D, what are we going on next? D6. So for D6, all we have to do is say, using our constructor, we say dict, and we can see all the methods. Just pick from keys, and then we pass in our variable, which is from keys itself, from keys as a variable, and the next thing is to put comma of 0. Okay, so all right, this is the next one. And finally, using the zip function, which we are already familiar with, because we have done this before. So keys, you can say, just use the same thing we've used as before, name, city. However, these are just variable names. We can name them anything. We can name them X and Y, okay? But variable names are meant to be descriptive, okay? That's why we're using keys. And then we have values. Then we can say string. Okay, I don't remember the guys. Oh, good. I still have it copied. The city again. And then the age, which is 45. Then finally, we can say user. No, we're not using user. We'll say D7 for us, equals to dict our constructor. Then we can say zip, right? Remember zip. Then we pass in the two keys, comma, values. It's as simple as that. So D7. Now we'll run everything from the top. So let's go there. So here we'll print D1 and D2, D0, print D0, comma D1. So we run that. You can see the first one is an empty list. So let me put a comma between them. Okay, so first one is an empty list, the second one is a list with a value. So here we're printing D3, D4, and D5. Okay, so come here and print D3 from D2, comma D3, and then D4. All right, so we have D2, D3, and D4, and let's see what that looks like. So for the first one, it is an empty list, right? An empty dictionary. The second one, you can see this became the key, and then this became the value. Just the same way we have its key and value, word and meaning. Okay, and lastly, the third one, you can see it looks exactly the same, no difference at all, using the list of tuples, right? You can see one good use of tuples acting like a key and a dictionary because they are most times in pair. Remember, for you to use a single value in tuple, you must add a comma to it. So now I'll just print D5 since that's the only thing in here. You can see 1 becomes the key, value becomes 1, 2 becomes the key, 4 becomes the value, 3 key, the square value, 4 key, the square value, 5 key, 25 value. All right, so let's print D6 here. You can see from keys, so we have these because these are the keys, right? From keys, then we have all of these in there. I'm not sure how this got here. It's okay. Let's print D7. You can see that it's exactly the same way using the zip function. Now that we have seen a couple of ways to create dictionary, you might want to go over it again slowly to memorize them, but majorly pick one or stick to one, except you're faced with a complex kind of data that you want to convert into a dictionary. Then you can now think of which one to go with. Okay, so let's get into it. Now we want to create a dictionary that, say for example, represents a student profile. Now we want to get into what we want to do. So let's start with the student profile. You can just say student student underscore profile end. And then we'll say for this, we'll open a curly bracket. Everything can be on a single line, but for readability as usual, we'll break it into separate line. So say name, we can say same person. Okay, then we'll put a comma. Then we'll say age. Keys are always string. Okay, keys are always string. Then we'll say 45. What other profile can we add? Major. String. I just said that now. Major. And as data science. Then GPA. That can be floats. You can say 4.1. And then courses, right? We want to have courses. So courses, and that can be a list of courses, right? A list, it can be a list. We can have it in there like that. So we can say Python statistics, and let's say machine learning. Right, so this is what we have, and we can now print student profile down here and say print using our formatted string. student profile. Say student profile, and down here we can print the type of student profile. Type. So run this and we can see student profile name, age, and the courses the person is offering. Okay, and we can see if we check the dictionary, it says what? The type, I mean, it says it is a dictionary. All right. So let's say, for example, we want to access the student name or the student course. Okay, we want to access the student name and the student course. So we'll do, let's just do a print directly. And then we'll say f string student name. That's accessing values. Remember, it is not ordered. So since it is not ordered, how do we access the value? So we'll say student profile. Then we use a square bracket as usual, but we don't pass in an index. We pass in the key. And if you look at it, automatically, once you put square bracket, the keys appear up here. So we can just check the name, select the name, and it does it for us. It just puts it in single quotes for us like that. So this will give us the name. So if we print this, student name, Katrin. Right? So what if we want to get the major? We want to print the courses. And let's say we want to print the courses, or let's say we want to start with what is the person studying first. All right? We want to get the major of that person, and then we'll say students course. So since we use major as the variable, let's just say students major. Okay. And then we put in, okay, we have our f string, so student profile dot course. All right. So this is what we have. And yes, you're probably thinking about something in your mind, and I will run it anyway. Yes, exactly. So it's saying, hold up. We don't have anything called course. Okay, we don't have anything called course. So what do I do? Or what if I want to get something that is not available? Remember, we have something similar in, and I'm say this will throw an error. This throws an error if unavailable. So just like remove and discard, okay, we have a safer way of accessing values. So we can say dot get, and in this case that uses parentheses, not square brackets. So dot get, and if we run, let me comment this out because that will throw an error again. And you can see it says none, so it's going to return none if it doesn't have it. That means we don't have any course, which makes more sense to us. No error, returns none if NA. All right, just do it that way, if NA. So that is what we have for this. Now let's say we want to get all the courses. You know how to do that. So what you should do next is try to grab courses, GPA, and the rest of what we have in there. But let's see how we can grab our courses together. And why I want us to do that is, what if I tell you to grab just the second course? But let's grab the courses together first, and then we'll see how to do it. So take this. We just use our square bracket notation in this case. So copy this, then we'll change this to courses. Okay, so let's grab all the courses. Student first course. So think about it. How do you think we can grab the student first course? Okay, how do you think we can grab the student first course? So the students courses in plural. Now we want to grab the student first course. So since this is a list, right? All we have to do is pass in 0. That is it. So nested or no nested, we grab it that way. Students first course is Python. And it's as simple as that. So quickly, let's look at how to add value, update value, delete value, or remove value. So we want to add value, say student profile. We just create it as we had a value as if the key is existing, the same way we want to access, but we now put an assignment operator. Okay, so let's just say University of Tech or Tech University. So it adds a new column called it has a new key called university, and the name will be Tech University. Okay, it's as simple as that. So we can print the updated profile, print updated profile, then we'll say student profile. Now before we print that, let's update the age. Let's say it was an accident that we had 45. Okay, so we can say age, and then we'll put in 25, just like that. So it updates the 45 there and prints 25. So let's see what it looks like now. You can see Katrin is now 25, and if we scroll all the way down, we now have the university added, just like that. So removing a value. How do we remove the key and the value? We say del. The keyword is del. Then we say student profile, and then we'll put in the key. What should we remove? GPA. So once we do that, it deletes the key, and of course, if the key is gone, the value is also gone. If the key is gone, the value is gone. So just call that so let's say removed students GPA from public view. Let's just put a message there like that, and if you look at it, oops, the GPA is gone. We don't have the GPA again. Look at it here, just after data science, but in this case it is gone. So we use the keyword del. All right, so what if we want to remove some courses, or want to remove the courses? So we can say student profile, or let's put that in a variable. Let's say popped courses, and then we say okay, yeah, student profile dot pop. Then we'll put that there, and then we'll pass in our courses, just like that. Passing the courses, and then we can now print out the pop courses. Okay, we'll print out the pop courses, and then we'll print out the profile after the pop courses. Okay, so take this, copy it, paste here. We can just let them stick together. So by default, it's meant to just display what it deleted if we run this on its own. So, but we saved that thing inside the variable pop courses, and then this can be um you can say let's add the pipe symbol, student profile after popped courses. How should we put that? How should we put that? Can use a comma. I'll say profile after popped course. Then we can say student profile. Student profile, and we'll come back here and put in popped courses. Popped courses. All right. So let's print that and see what it looks like. Okay. So this is throwing an error because we have it in the same cell. Okay. So it's saying, oops, you already deleted it. We don't have it again. So let's cut this out into a new cell, and then we'll add the code. All right. So run that now. You can see the popped courses, and after popped, courses are gone. So we can remove values doing that as well. Okay. So finally, we want to look at getting the keys, the items, and the values. So just do a print student profile. But sometimes you might have a dictionary and you don't know what is inside, so you want to find out the keys so that you can be able to access the values, right? So you say, let's make it faster, f student keys. You can say student keys in this case, so it should just be keys, curly brackets, closing quote. So copy, paste, this will be values, and then items will return a tuple. Okay, items will return a tuple in pairs like that. Items. Okay, so let's print this. So you can see keys, name, age, major, university, the values, dict values. You can see what we get, and dict items in tuples. Name, Catherine. That means we can also create them this way. You can see tuple list. Then we use our constructor. We did this earlier. Okay. So looping over a dictionary. How do we loop over a dictionary? We can just print in, for example. Now, in this case, since dictionaries are key value pair, we do not need, and in the items, using the items, you can get a tuple, right? So we can do something similar to enumerate. When we're looking at for loop, we can do something similar to what? To enumerate. So we can just say, let's just print something first. Looping over a dictionary. Looping over a dictionary. And then we want to say for key and value in student profile dot items, right? So we can print what? We can print the key and we can print the value just like that. We can print the keys and we can print the value. So we can just say, let me use two more indentations. Print key, let's say f keys, let's just do it this way, square brackets, key, colon, square bracket again, or curly brackets, value. Okay, so for individual ones, I'm printing the key and value. So you can see looping over a dictionary. Let's add a line, \n. Let's also add the line before it, \n. All right, so looping over a dictionary: name, Catherine; major, age, and university. And yes, this brings us to the end of dictionary. Do not forget, to access more methods of a dictionary, you just have to use the dot notation with the variable name that is holding the dictionary. And this goes for all the rest of the data types we've covered as well. Whenever you save anything into a variable, you want to know what stuff you can do with them in terms of methods you can apply. You just have to use the dot notation and then you get that out of the way. So pro tip: dictionaries are fundamental for organizing data in a structured way, especially when dealing with records or configurations. They provide very fast lookup by keys, right, making them efficient for many data science tasks. And like I said when we started data structure, I said I push down list and dictionary because we use them more than we will use tuple or set. Right? And yes, this brings us to the end of let me close this, end of the data structures. All right, so mini exercise for you. So create a list called data points with this. Add 60 to the end of the data point and insert 5 at the beginning. Remove the first occurrence of 10. You see, we have 10 twice. Using slicing, create a new subset data list containing elements from the 12th to the 5th position inclusive. That means this time you should include the 5th position. But that's just for you to think a little bit. Just think a little bit on how to get that into it. So create a tuple of colors, an RGB color, and try to change the element to 50 and observe the error. Okay, from data point, create a set called unique data to find all unique values and print the unique values. I believe you know how to do that already because sets can help you remove duplicates quickly. So create, I think we've done this. We've done this already, but still do it again anyway without looking at what you did before or without following the video. But if you get stuck, you can always come back to the video. So find the union and intersection. You can use both ways, using the method and use the operators as well. So using a dictionary, I create a dictionary for product inventory with at least 3 keys and their quantities. So something like this. We have a laptop in stock, that's 10. We have 10 laptop in stock, 50 mouse in stock, and 25 keyboards in stock. Okay. Update the quantity of the laptop to 8 and add a new product monitor with the quantity of 15. Now print all the names and then all the quantities value from the product inventory. So I want you to have fun with this. Make sure you try every exercise out. So I can keep it here so that you can maybe take a screenshot, snap this part, and make sure you do it. And to share your work and your notebook as usual, once you do it on Google Colab, you can just share your link in the Telegram channel. The link will be in the description below. So yes, I want to see what you do and see how well you're doing it. Okay, so for that, we'll see you in the next one where we'll be looking at how to handle errors. All right, till then, keep practicing, and keep practicing. I'll see you in the next video.